Now my next question is, let f(a), this is the domain, codomain, it is be a continuous function, and this be defined gx, this is defined. So now here this is continuous, it is given to you. So now it is, we are only concentrated on gx. So to check the continuity of gx at constant functions, so let us check the continuity, because at a and at b, these are the testing point. A and b are the testing point, these are the testing point. So let us check the continuity at a, means let us check the continuity of gx for x is equal to a. So your left hand limit will be limit x tends to a minus fx. So your a minus fx less than 0, this is how much? Oh, so not fx, this is gx, sorry, gx, this is how much? This is 0. And your right hand limit, here you see, that is limit x tends to a plus, this is a minus gx, this will be how much? This will limit x tends to a plus, so this will be from a to your x will, this upper limit is a, so ft dt, because your upper limit and lower limit are the same, because your upper limit and lower limit are the same, so your result will be 0. So it is continuous. So it is continuous at x is equal to a. Now again let me test for b, for x is equal to b. So left hand limit x tends to a minus gx, so this will be sorry, at b, this is b minus, so less than b, this is your, so this will be limit your x tends to a minus, this will be how much? A to a, and sorry, this is b, again I am writing the same thing. So a to b ft dt, and your right hand limit, that is limit your x tends to b plus, that is gx, that is equal to limit your x tends to b plus, so greater than b, this is a to b, this is your ft dt. Here we find that again left hand limit is equal to right hand limit, so it is continuous. So it is continuous at x is equal to b. So it is both continuous at x is equal to a, as well as at it is continuous at x is equal to b. Now let us check the differentiability. For differentiability, here we are going to apply the Leibniz theorem. This is the Leibniz theorem. We are going to apply the Leibniz theorem. This is not included in your class 11 or in your class 12 course in CBSE. This Leibniz theorem, Lebni, Leibniz theorem, this is not included in your course, but to solve this problem Leibniz theorem becomes necessary. And according to Leibniz theorem, if your gx is your phi psi to f psi, your ft dt, then your g dash x will be phi psi into phi dash psi minus g, not g, that is phi, that is phi psi into phi dash psi. This is your Leibniz theorem. So when I am going to apply this Leibniz theorem here, g dash x, this will be 0 if x less than a, and for this it will be, so your see phi f psi is your x, so phi psi, so this will be phi x, this will be phi x into phi dash psi, that means this phi dash psi, so differentiation of x is 1, so this is 1 minus again g psi, that is that will be sorry, phi psi, your phi psi is a, sorry, your phi psi, this is your sorry, this is your phi psi, so this is your phi x, phi x, and uh, uh, phi x, and your this phi dash psi, this a, it is a constant, so it is 0. So your it is if for x greater than equal to a and less than equal to b, and for this it will be 0, because this is a constant, because this is ultimately a constant, so your result will be 0 if x is greater than b. So let me modify it a little bit. So your g dash x will be 0 if x is less than a, and it will be phi x if x is greater than equal to a and less than equal to b. It will be 0 if x is greater than b. For here we find that these are your testing point, G and B, your testing point, and in this testing point we clearly find that at A and at B it is not differentiable, because at A its value is 0, and at B at A minus your value is 0, and at A plus it will be FA, and at B minus it will be FB, and here for x greater than b, b plus it will be 0. So it is not differentiable at a and b. It is not differentiable at a and b. From this it is clear, because these are the testing point, and this is the Leibniz theorem which we have to apply to find g dash x, which is not included in your class 12 course, but you have to learn this so that you can be able to solve such type of question. So your answer will be gx is continuous but not differentiable at a, and gx is continuous but not differentiable at b. So these are your two options which are your correct. So this is how, here again I am telling you Leibniz theorem, that is psi x. So here it will be f x dt, and then into differentiation of x, this is 1, this will be 0, again psi x, this will be psi that is x, and differentiation of this constant is 0, so this is 0, so ultimately this becomes 0, so this is equal to your fx. This will be this is your this will be your result. So it is continuous at x is equal to a and x is equal to b, but it is not differentiable at x is equal to a and x is equal to b. Now my next question is, for a real number this denotes the greatest integer less than or equal to y, then the function this is discontinuous at some point as continuous at all x, but the derivative f dash x does not exist for all x, exists for all x, but the derivative f double dash does not exist for some x, f double dash exists for all. So here you see that your function fx is equal to 10 pi x minus pi by 1 plus x square. So here sorry, this is a greatest integer function. So here this is your, this is what, this is your greatest integer function, greatest integer function, integer function. So that means the value of this will be integer, this value of this will be integer. So the value of this is integer, that means your this will be 10 n pi, n, because n belongs to some integer, and this is your n belongs to some integer. So fx, we can write fx like this, 1 plus this whole square, and again we see that this your 1 plus this can never be equal to 0 for any value of x. This can never be equal to 0. And your 10 n pi, it is always 0. So your your fx is equal to 0. So here your fx is 0. So fx is 0 this is not, so your here your fx is 0. So that means the your value fx will come out to be 0. So here that means fx is 0. So what is the result you get from here? That is a your fx is equal to 10 pi this now, but here discontinuous at some point x, it because your fx is 0, the result, because integer, the result of this will be continuous at all x, but the derivative of f dash x does not exist for some, and f dash x exists for all x, but the derivative f double dash does not exist for some, and f dash x exists for all x. So here your function is 0. That means function is 0. That means whatever be the value of x, your function is 0. That means whatever be the value of x, your value will be 0. So what does this mean? Whatever be the value of x, your y will be 0. So this is a constant function. So your fx is a constant function. This is a constant function. Constant function. So since this is a constant function, so f dash s exists for all x. I am repeating it. Here you see f dash x is equal to 0. So here f dash x is equal to 0. What does this mean? That means for any value of x, your this y value is 0. That means fx is a constant function. So when it is a constant function, your f dash x exists for all x. So this option is your correct option. Now my next question is, that is if f r to r is a differential function such that f dash this is greater than 2 fx for all x greater than r and f0 is equal to 1, then your fx is greater than e to the power 2x in 0 to infinity, and f dash x less than e to the power 2x in 0 to infinity, and fx is increasing in 0 to fx is decreasing in this. So here you see that your f dash x is greater than 2 fx. That means f dash x, it is what? It is dy by dx. It is greater than 2. Your fx is what? It is y. So here you see that here you see that here that means dy by y is greater than 2 dx. This is greater than 2x. So for x is equal to 0, we integrate it. For x is equal to 0 to x, to for all x, for x. So here this will be for 0 f your when x is 0, your f0 is 1, and for x, that is for any value of x, this will be fx. This will be fx. So here log y, this will be equal to 1 to fx, and greater than 2x, this will be from 0 to x. So this comes to be log fx minus log 1 is 0 greater than 2x. This is greater than 2x. So here base e, so e to the power, so here your fx, your this fx is greater than e to the power of 2x. Your fx is greater than e to the power of 2x. Now so here you see f dash x, it is given to you, it is greater than 2 fx. So automatically this fx is greater than this, so this is greater than this is greater than e to the power of 2x. So here f dash x is greater than e to the power of 2x. So for 0 to 0 to infinity, for yes 0 to any value of x, so your this option, a option, is correct. F dash x, this is f dash x is greater than f dash x, huh? Because it is such that for all x, then this will be f dash x. This will be f dash x. F dash x is um, f dash x is greater than e to the power of 2x. So this is your option. Option A is your correct answer. Now my next question is, this f r to r be a continuous odd function which vanishes exactly at one point and f1 is equal to half. Suppose that fx is equal to this for all x belongs to this, and gx is this for all this, and if limit fx is 1, we have to find this f1 by 2. So here you see that your fx, it is given to you minus 1x and ft dt. So here your f dash x, if you apply if you apply Leibniz theorem, then your this will be fx, because uh, according to Leibniz theorem, this is f psi x. F psi x is fx, and differentiation of f dash psi x, here this is x, this is 1, and again here you see differentiation of minus 1 constant 0, so it comes out to be this. And again, if we for g dash x, if we apply Leibniz theorem again, no sorry, gx is your this x t f f t and then modulus dt. So here if we apply Leibniz theorem, so this becomes your x f then f x, this is your this, if you apply we get Leibniz, from the Leibniz theorem we get this. Now I'm going to apply L'Hospital rule here. If I apply L'Hospital rule, then therefore limit x tends to 1, this will be f dash x by g dash x, and this will be equal to 1 by 14 if we apply L'Hospital rule. I am applying L'Hospital rule here. L'Hospital rule, if I apply as hospital rule, so here this will be this comes out to be this 1 by 4. Now here placing the value of limit x tends to 1, your f dash x is fx, and here your g dash x is x x, then close g dash this close and this close fx gx here, and so this will be equal to 1 by 14. Now when we remove the limit, that means f1, and this is 1 f of 1, so here this will be 1 by 14. So again f1, value of f1 is half, so this will be half, and f half, so this will be equal to 1 by 14. So again, if you now so 1 by 14, so this is equal to 1 by 2 f half, so this is equal to 1 by 14. And so 1 by f your half, so this is equal to 2 by 14. So here your f half, it comes out to be 7. So this is your answer. So this problem is based on Leibniz theorem and on L'Hospital rule, and your f half, it comes out to be 7.